Oh yeah. What's up, everybody? How we doing today? Welcome to another wonderful episode of Model Monday Live. I am very excited to be here today with all of you. It is a crazy weekend we had. We had an awesome, epic set of showdowns at the tournament. We had I guess a little bit of drama. I don't think it was a lot of drama, but a little bit of drama with regards to a little technical difficulty in one of the matches. Serious surprise during that match. At the end of that match, basically we thought one of the runners was out of contention, and it turns out he was modeling in the background and just absolutely crushing it. And once again, we ended up with a kind of neck and neck showdown at the end. So very, very cool stuff this weekend during the tournament. If you haven't had a chance to watch it, I did go through and bookmark everything in the tournament. I'm still working on putting together the summary from the tournament, so I'll try to release that video a little later today so that everybody can kind of catch up on that action if they don't have time to watch the full thing. But I encourage you to watch the full thing. We had a very special guest in the chat. I'll let you guys watch the video if you want to see who that guest was. But really, really great battles. Looks like All About Science and Mathematics was in the live stream this weekend and saw those battles, and wow, yeah, crazy. And of course, Space Claim was in there last weekend. Yeah, Ansys Space Claim, and just totally tore it up last weekend too. So really good stuff this weekend with the tournament. But I know most of you are here for the live 3D CAD challenges for the chat, and I got a couple of good ones today, so I want to really get right into it today, kind of move this along. I want to show you guys the second one before we hit the half-hour mark. So before we get to 11:30 East Coast time, I want to make sure that I'm showing you guys the second model, because both these models are pretty complicated today. So let's get into it here. Like I said, over the weekend, we did some really cool matchups. We had Oliver versus Aaron C., Fusion 360 versus SolidWorks, a really nice matchup there. I'm going to show you guys how to model some of the challenges that they did this weekend today, live, using Onshape. And we also had Onshape, Imans from Onshape, going up against Ricardo Jean using SolidWorks, and that was really, really neck and neck. I wish I could have had 5 more matches for them to go against each other, because they were so closely matched, and those are always the most exciting matches. So really good stuff this weekend. Congratulations and thank you to all the runners, and thank you to my special co-host, co-commentator, Chris Smith from SolidBox. Totally crushed it on the co-commentary. So today we'll talk a little bit more about the tournament. I'm going to give you guys 2 3D CAD speed modeling challenges for the chat to try to accomplish, and I'll show you some moves in Onshape. If you want to support the channel, be sure to hit that like button. Looks like we got 12 people watching. We got 5 likes. Let's see if we can get that up to 12 likes so that our watchers and our likes are all nice and matched up. Of course, if you're watching this in the recording, throw a comment down below. That definitely helps the algorithm. And subscribe to the channel if you like what we're doing over here with these 3D CAD matchups and 3D CAD speed modeling challenges. Like, share, done. Nice. Appreciate that. All About Science and Mathematics. Very, very nice. If you guys haven't checked out our main sponsor for the channel, SolidBox, be sure to check them out, mysolidbox.com. They've done a lot to support the channel, a lot to support Model Monday Live, and they're even our sponsor for the blue bracket during the tournament. SolidBox really tries to provide professional workstations and professional solutions for professional engineers. So whether you need hardware, like a new laptop, a new desktop, or whether you need some consulting, or you just need some work done for you, fluid dynamics analysis, finite element analysis, the team at SolidBox can really do it all. So check them out, mysolidbox.com. And today we're going to talk about our live CAD speed modeling challenges. I'm going to show you a 2D print on screen. You're going to grab a screen capture of that using Windows Snipping Tool or Snagit or MW Snap. Shout out to MW Snap. And you're going to try to turn that into a 3D model. Guthermi is in here in the chat. What is up? Welcome, welcome. Thanks for joining us. Let's go. Yes, indeed. Let's go. Let's go. So I'm going to show you guys the 2D print. You're going to try to calculate the mass and enter that mass in the YouTube chat. We're going to find out who is the fastest speed modeler in the chat. And the basic rules are you can use any CAD package as long as you can input density and output mass. And you want to make sure you use the specified precision on these challenges, otherwise you're probably going to be out of spec. And the first person to answer correct in the chat will be declared the winner. And so we can see here that the CAD Speed Modeling Challenge has the units that are shown on screen here. If you haven't done this before, take a moment, do a screen capture. That way you can make sure that you have your templates set up with the correct units, and also make sure you have your materials set up with the correct units. Like I used to use SOLIDWORKS a lot, and so SOLIDWORKS I used to create these challenges, and the materials from SolidWorks use these densities by default. But then I moved over and started using Onshape a lot. And with Onshape, the material called plain carbon steel doesn't have exactly this density, so I had to go in and create a custom library in Onshape to have these densities readily available for me. So I'll talk about that a little bit more in the live presentation. But the point that I'm making here is if you're using a different CAD package, make sure that you've got the correct material density. Otherwise, you're not going to come up with the correct answer. And the advanced rules are that this is meant to be fun and good-spirited. This is something that occasionally I will make mistakes. I do spend a lot of time auditing these drawings. You know, one of the things that I'm very proud of as far as the collection of drawings that I've accumulated is that they all have everything that you need to create a 3D model. A lot of times if you get a drawing from university or just a random drawing from the internet, it's missing dimensions, and you can't actually make the thing that's on the print without like assuming or just guessing what that missing dimension is. So it is nice to know that I have a collection of these drawings. This collection is going to become available when we redo the website. The new TooTallToby build is going to be coming out in the next couple of weeks, and you're going to see that you're going to have the opportunity to get a hold of these prints as just regular 2D PDFs, make it a lot easier for those of you out there that want to have a nice collection of drawings. So it's all coming. I'm very excited about that, but occasionally I still do make a mistake, miss a dimension, something like that. So question coming in here, can you make a video on how to add a custom library in Onshape? Not only can I make a video on how to do that, but I already did. It's on the Onshape YouTube channel. There's a playlist on there. I will point to that once we get this first challenge going for the chat. But yeah, great question. Thank you, Omri, and All About Science. And don't worry, I got you taken care of. It's already out there for you. You can even search my library in the public space and just pull my library down so you don't even have to recreate it. And finally, the Ivan exploit is permitted. We saw someone in the tournament this weekend start to use the Ivan exploit and then decide to do a little flex and actually make the model legitimately. And so that was pretty tight. Shout out to Amance for going the extra mile there, almost costing himself the point, but actually not using the Ivan exploit. That was pretty cool. All right, guys, here we go. Let's get into this first challenge. Like I said, the challenges today are a little bit on the complicated side. I think they're going to take you, it's going to take you the full 20 minutes. So my goal is going to be to show you the second challenge in about 20 minutes. So let's get into this first challenge here. Your job is going to be to take a screen capture of this and turn it into a 3D model, calculate the mass, and enter that mass in the YouTube chat. First one to get it correct in the YouTube chat is the winner and earns the point for today. Here we go. 3, 2, 1. Go! What is the mass of this part in XXX grams? The tolerance is plus or minus 1 gram, and the material is listed there in the title block. 1060 aluminum alloy, density of 2,700 kilograms per cubic meter, and this part is called wedge bracket. And this part you can see here in the drawing has some some pretty cool geometry in the drawing for you to work with, to examine, to try to figure out what's going on here. I guess in the lower left corner of this drawing, that radius 126 and then the linear dimension 126, that's really just meant to reinforce the idea that the center point of that radius is collinear with the bottom of the base. The radius is, it's the same as that linear length because the center point is not like hanging out in space somewhere. It's it's right at the bottom of that base, and you can see in the top view that the center point is 3 millimeters from the end of the model. So that technically that extra 126 there should be in parentheses. I do make mistakes occasionally. That's not a big mistake. It's just wanted to kind of point that out to you. It's really just trying to show that the center point of that arc is collinear to that lower base of the model. So let's see what happens here. Looks like we got about 18 people in the live stream today watching live, and your job here, your goal is to attempt to take this 2D print, turn it into a 3D model, answer the question, what is the mass of this part in XXX grams? I'm going to do a quick audio check here and see how the music sounds. I think it sounds perfect. All right. Excellent. So I think with that, we are ready to move on. Again, your job here is to grab a screen capture of this. So take a moment, grab a screen capture of this. I'll give you guys just another moment here to make sure that you've had enough time to do that. And while you guys are doing that, I will bring up that YouTube channel that I was talking about a moment ago. All right, good. So hopefully that was enough time for everybody. Again, your job there was to grab a screen capture of that and make sure that you have that on your... A lot of times I'll put that on my second monitor. And here you can see the Onshape YouTube channel. It's youtube.com/@Onshape Inc. It's a little bit lengthy there. Usually I just go to YouTube and search it, and then I just bookmark it. And then over here you can see that there's a section that says playlists, and in these playlists, one of these playlists is called SW Expert Learns Onshape Ongoing Series, and you can see it says View Full Playlist. And if we do that, we scroll down here a bit. One of the playlist items here is create a custom material library in Onshape. So in that video, I show you how to go through. I show you how to create that custom materials library, how to add it to your Onshape environment so that you can utilize that library. And you can even search for my library and just download it. You don't have to create your own. You can just search for my library and then just add it to your documents because it is in the public space. That's a cool thing about Onshape. Kind of a double-edged sword. I know a lot of times people say when you make something in Onshape, it is in the public space, and that is true. If you're using onshape.com/free, the totally free version of Onshape that runs in a browser, so you don't have to install anything. But the downside is that everything you make is in the public space, so anyone can search for anything that you make until you get onto the paid plan. The cool thing is that means you can search for anything that anyone else has made, and all you need to do is click on that thing. So if you're interested in, like, let's see if we can find something that a user made, like this concept vehicle by Matthew Jane. Well, you can just click on that, and that vehicle opens up in your session of Onshape. Look how quickly that opened. And you're able to examine this thing as an assembly. You're able to move components around. You're able to see actual dynamic assembly motion based on the mates in that assembly. And you're able to make a copy into your workspace so that then you can start making your own version of this thing. Now, obviously, you can't change Matthew Jane's files, or not files, but his documents. You can't change his documents. Because you don't have permission to make changes to his project. That would be a crazy system if everybody could just change everybody else's files. But you can certainly make a copy and then make changes to your own and kind of springboard off of this design, or maybe search for an item that you need for your product. Search for a wheel in the public space, or search for a knob, or a guitar or something like that right in the public space. So pretty good stuff here. Definitely really enjoying my time in Onshape, as I've mentioned to you guys in previous episodes of Model Monday Live. Alan's in the chat, says, at work, we'll try all this stuff tonight. Just getting into CAD using 3D Experience SolidWorks Connected. Okay, another solution that's out there. So good to know that we've got people using all different solutions that are out there. And, and you're in this wonderful world of TooTallToby Model Monday Live. All CAD is welcome. Good luck on your journey, Alan. Erwick, what's up, my man? Thanks for joining us. So yeah, the tournament this weekend was, like I said before, was totally epic. 2 weeks ago on Saturday, we had the July 15th matchup between Fabian and Ty, where Fabian was able to come out victorious. And then this past weekend, we saw Imans versus Ricardo Jean. Definitely I don't know if this was the closest match we've had so far, because the match in the black bracket with Fabian and Ty was also very, very close. The answers were coming in within just like a second of one another. But it was just kind of a surprise in this match with Imans and Ricardo, because Ricardo's screen didn't share properly on Zoom, but he was still modeling. And so when we saw Imans go through and create the model, and then we saw Ricardo submit his answer a second later, it was just such a cool moment. It was a real surprise. And then they got to model against each other in the second one. We all got to watch their modeling technique. I'm going to do one of those models today so you guys can kind of see how I would approach it. What's up, Edgar CHL? Welcome. Thanks for joining us. And Oliver versus Aaron, also an awesome matchup. It was really cool to see Fusion 360. This is the first time we saw Fusion 360, first time we saw SolidWorks, and first time we saw Onshape in the tournament this year. And so it was cool to see Fusion 360, and it's just always fun to see the way the different CAD packages operate, watching them, streaming live and watching the way they think through the challenge, but also just kind of seeing the different features and the different user interface. A lot of these CAD packages I've never had the chance to run. I've never had the chance to even see. And so in the tournament, it's kind of cool that we get to see them actually functioning and kind of how would you do this in SolidWorks? How would you do it in Fusion 360? Kind of seeing two masters showing us how to create these different features. So excellent matches this weekend. Huge thank you to all of the runners. Of course, be sure to join us July 29th. We're going to see Onshape versus SolidWorks. Golden Spamfish going up against Momin. So check that out on Saturday, July 29th. We're going to see some really good matchups there. And also on July 29th in the blue bracket, we got old friend of the show, Muhammad, using CATIA V5. I think this is his third year in the tournament using CATIA. So Muhammad always shows up, always gives us a great demonstration of what it looks like when a pro uses CATIA. It's another one of those CAD packages that a lot of us haven't had the chance to run, and so it's really cool to get a chance to see it in action. And we see here that Muhammad is going to be going up against Res. Res is going to be used in SolidWorks, also from the United States. And that's going to be a great matchup as well. And we got AMO Alex in the chat. What's up, Alex? And already coming in with an answer. Very impressive. I'm not going to say if that answer is correct or incorrect, but I am going to say that Alex is going to be in the tournament a little bit later on. And it's great practice here in Model Monday Live. I can't think of a better place to get your practice in and kind of get your nerves out and see what it's like to actually try to compete against other people than here in Model Monday Live. You're competing against everybody from around the world, but you still kind of have that privacy bubble around you where it's just you on your screen. You're not sharing your screen yet, but this is a great chance for Alex to get some practice in before his big match comes up. And anybody who's out there who's in the tournament, it's really like a nice opportunity, kind of proving ground here before it actually comes to tournament season. Or should I say tournament time? We're already in the season. So, like I said, on Saturday, we had some great matches between Oliver and Aaron, and the first model that they were challenged to create was this model here, the guide, 23-T-14 guide. And this was a pretty cool matchup. We saw that in this matchup, we had Aaron, who was running SolidWorks, and he just cruised through the whole model, but he made a mistake when he was creating the model. And the mistake that he made had to do with this dimension down here. And he did it right in the very beginning of the model, and then he made a second mistake. I think that the second mistake was with regards to the width or the location of this rib. And so something interesting happened where he got to the end of the run. He finished the model. He submitted his answer. I said, I'm sorry, Aaron, you've submitted an incorrect answer. And so you have one more chance to submit a correct answer. And so Aaron started going through, and he found one of his mistakes, but he didn't find the other. And when he found that first mistake, he said to himself, you know what? That's probably what it was. And so he submitted the answer again, and it was like, oh, I'm sorry, Aaron. That's once again an incorrect answer. And so we're going to put the clock up. We're going to give your opponent 5 minutes to solve this thing. So we gave Oliver 5 minutes. Oliver wasn't able to solve it in 5 minutes either. So it ended up being a push. And it was just kind of one of those situations that I think are really interesting in the tournament, where sometimes if you make one mistake and you go back through and you find it, okay, you're good. You can submit that correct answer. But if you make two mistakes, well, it's really easy for you to find the first one and to think, oh, that must have been it. But in this case, it turned out that he didn't quite find the correct answer. So, lessons learned from watching people in the tournament, and a good lesson for anybody who's in the tournament in the future. It's really a tricky balance of trying to get that answer in before your opponent, because you never know. You can sort of see your opponent's screen on a delay, but you never know when they're going to do like 2 or 3 little quick moves, and then they're done. And now they're submitting the answer and they're coming in before you. But you got to kind of balance that against really going through and checking your answers. So, all right. So good to see some action here in the chat. We see some more answers coming in. Of course, in Model Monday Live, you can revise your answer as many times as you want. And we see that looks like Alex and Omri are going at it here neck and neck, kind of coming up with some different answers. So we'll see what everybody else in the chat comes up with. But I've got about 9 minutes to finish this model. And so what I like to talk to everybody about during Model Monday Live is just kind of what a professional would think if they were presented with this model, whether it was a 2D print on the shop floor or a napkin sketch that somebody hands you, or even just an idea. You know, maybe I just have an idea. I need to create a mount for a soldering. This looks like it would be like a mount for a soldering iron. So the soldering iron is gonna, go down in here. It's gonna sit in this hole. It's gonna have its, it's usually they have like some kind of a sleeve here, and then the soldering iron needs to sit in there. And so I'm gonna create a little mount here that I mount on the side of my workbench so that I can set my soldering iron down really easily. While I'm working, I don't have to completely cool it down. And so I'm gonna, I don't know if that's really what this thing is. I'm just saying, that maybe that's what it is. You have that idea, so now you got to model it up. Well, the first thing that I always ask myself is the model symmetric? Can you draw a line down the middle of the model and it's the same on both sides? Because if it's the same on both sides, then that's going to help you figure out where to create the origin. It's going to help you figure out what your starting sketch is going to look like, and it's going to help you figure out what your very first feature is going to look like. And so in this case, the model is symmetric. Whenever we see the CLSYM symbol in green here, that means that the model is symmetric. So now I know kind of that the origin is going to be somewhere in the middle. Now the next challenge is what's going to be your starting feature in this model. And I think that in this model, it makes sense to either have this section up here be your starting feature, or this section down here could be your starting feature. And the reason that I say that is because those two features have, all the dimensions are coming from those two features. And it gets to be a little arbitrary which one you decide on, but most of the time in the engineering world, we decide this feature because this feature represents kind of the base, or it represents the thing that's going to be mounted to the other thing. It just kind of like represents an anchor point in the real world, and that's usually an intuitive place to start your design in the 3D CAD world. So that's where I'm going to start. I'm going to take a screen capture of this thing. I think what I'll probably end up doing as far as a game plan goes is I'll probably end up creating this shape here, creating the little curved area on the bottom of that shape, creating this shape up here, creating the bridge that goes between them, and then I'll finish up by creating the holes down here in the base, the hole up here in the top, and the chamfer that's going around here. And this, how do I know that that's the order? I mean, the simple answer is I just know from experience. I just know from, having built models like this over and over and over again, and just a lot of experience in the world of 3D CAD. And so, how do you get good at anything? You just got to practice, practice, practice. So I'm going to create a new document here in Onshape. I'm going to call this one 23-T-14-guide. This means that if you want to see this model and in 3D, you could just sign up for a totally free account, onshape.com/free, and then you could search for this text string in the public documents, and then you can open up this model too and take a look at how I created this model. So I'm going to start out by creating a sketch here in the top, or on the top plane. I think what I'll do is I will create, you would probably create the origin either at the center of this shape, or you would create the origin at the midpoint of one of the edges. This gets to be a little bit more nuanced and a little bit, honestly, a little bit less significant. It becomes kind of arbitrary, which decision you end up going with. I think then what I'll do is I'll pick the origin itself, and I'll pick this line, and I'm going to add a midpoint relationship between them. And then once I've got that midpoint relationship, I'm pretty much ready to fully define this sketch. So it looks like this is going to be 65, really from center to center, and then this is going to have a radius of 40 or a spacing of 80. And now I'm ready to turn that into an extrusion. Now, what I could do is I could get in there and start drawing the geometry for those holes as well. Onshape does a great job in this scenario of letting you create the really all the geometry that you need. So I could get in here and create these holes here, and certainly I could mirror these, but a lot of times if you learn how to use auto dimensioning, it's just as fast as mirroring. Now, this is really a speed modeling technique more so than a real world. In the real world, you'd want to either do that with a hole creation tool, or you'd want to do it with at least with a mirror. But you can see here that, like I said before, Onshape does a great job of grabbing all the geometry that you need for that particular shape. And so this is going to come down to a depth of 22 millimeters, and I'm going to reverse the direction. I do see some chat coming in, but I'm trying to finish this pretty quickly here, so I'm going to just hold off on responding to the chat until I get done with this challenge. So now that I've got that geometry in place, I'm going to select this face, begin a sketch, get normal to. I'm going to take this bottom edge here and convert it. I know this drives people like Airwick nuts when I go through and convert stuff, because I could just use imprinting, but sometimes it just makes it a little easier for me to utilize that geometry. So, you know, that's why I'm doing this convert. You don't really have to. You could just imprint, but it just makes it a little easier. And like I've said before, I'm kind of a, you know, creature of old habits sometimes. So make that 187 for the radius. And then this is the spot where Aaron misdimensioned. He made this dimension 20 instead of making it 20, or he made it 22 instead of making it 20. There is a 22 dimension right there on the print, which is probably what led to the confusion. And sometimes my prints do have, you know, intentionally tricky features. So I'm going to say this is going to be a remove and a through all, and that should cut out that bottom section. Yes, very nicely. I could also, at this point, if I wanted to, I could go back and show this sketch and then just reuse this sketch to also do a remove using these features. So Onshape makes it really easy for you to quickly remove geometry using, you know, the same sketch. Whoops, I didn't mean to get the whole thing there. There we go. And that's going to go down to a depth of 11. All right, so now we got our counter bores in there. We don't need to see that sketch anymore. There's kind of our base feature on this thing. Now what I'm going to do is I'm going to take this top plane and I'm going to jump into the new plane creation command. And I'm going to say that's going to be offset to a distance of 87. And now on this new plane that I just created, I'm going to create the geometry for that upper region. So I'm doing this, as you can see, as two different bodies or two different regions of the model. In Onshape, we would consider that two different parts. But in other CAD packages, you might consider it two different bodies. The thing that's cool about Onshape is that there's really not that much difference between multi-body design and multi-part design in a single model. It all kind of sets itself up to be added to an assembly later on. So now that I've got that geometry in place, I'm going to go front plane, begin a sketch, orient my view, and I'm going to, once again, make the Onshape community angry by using a convert entities command that I probably don't need to use. So I will convert these edges here. And that way I'm setting myself up nicely for this geometry to come off here and then come down at an angle, comes right down to that point, come over, come up, comes up to kind of a flat spot here, and then come over to this point. We'll make that guy horizontal. We'll make these two parallel, and we will add a relationship, a dimensional relationship between those two. That's going to have a dimension of 37. Oh, you know what? I never defined the location of that upper region, huh? I'm saying to myself, like, why does the upper region look so close? And the reason why is because it's close. So that's going to be 125 from the center point here. So let's grab that center point. Let's grab that point there. That's what we like to see. Nice, fully defined sketches. You got to fully define every time, like somebody once said in a song. All right. And this guy is going to have an angle dimension here of 50. Nice, fully defined sketch there. And then all I really need to do is just kind of close this thing off. I'll just close it off at the midpoint here. And I don't need to do any trimming or anything in Onshape. It kind of just knows what you want. It's kind of cool. Look at that. It just immediately knows that we want to just, grab the geometry that normally would need to be trimmed, right? So we're going to say that this is going to go out to a depth of 15, and that is going to be a symmetric or mid-plane extrusion. And then for our merge scope, we're going to merge it with both of these existing bodies. Boom. Looking good. Begin a new sketch on that top surface there. Let's jump into a circle command, and we'll make a circle here with a diameter of 46. And that's going to be a through all remove. And then we can finish up here with a chamfer, and that chamfer is going to have a distance of 8 by 45. And we'll say it's going to be here. Just picking that face, got both the top and the bottom. And then we do what's called the final spin, where we revolve the model around or rotate the model around. We look at the model. We say, does that have everything that we think we should have? I think it does. Let's go into our assign material option here. Let's look at the title block and assign that the material of plain carbon steel. And let's go into a mass properties and see if we got it right. So the answer that I'm coming up with here is a mass of, 2,500 grams. That's not right. One second here, guys. I don't think that's right. This is T14. guide. 2484 is what it's supposed to be. Why am I coming up at 2500? Uh-oh. We got a another bit of drama on this thing. So let's see here. Still at session 4, Model Mania. Nice. All right, let's see here. Okay, nice. I'm looking at the discussion in the chat, just seeing if anybody in there is helping me out. I'll tell you what, guys. Like I said, I have the second model that I've got for you guys today is pretty complicated, so I'm going to just put this on pause for a second. I will come back and resolve this. We'll figure out where the discrepancy is, because I'm sure I made a mistake along the way. But let me go back here to the challenge that I have for you guys today, and we will come back and we will look at that. That answer should be 2484 grams. And so me coming up with 2,500 is not correct, and I'm going to have to go back through and take a look and see what exactly happened. But like I said, today I want to make sure that we have enough time to get through these challenges. So let's take a look at our first challenge here for the what is the mass of this part, our first challenge for the chat. And we saw that the first answer came in here from AMO Alex with a mass of 621. AMO Alex revised to 612.24. And then Omri came in here with an answer of 615. Hold on, let me show you guys what I'm looking at here. So we see that Alex came in here 621. Alex revised to 612. Omri came in with 615. Alex came in with 615. Who else answered this one today in the chat? We got I said Guilherme earlier. Guilherme coming in here with 612. We got Raja coming in 615. We got Mihadi here today. What's up? Hello, how are you? Nice to see you in here today. We got, let's see here, Guilherme revising to 615. And I think that's it for the answers. Let's take a look here and see what the correct answer is. The correct answer is 615 plus or minus 1 gram. So very nice, and congratulations to everybody who took this challenge, and congratulations to everybody who got it correct. It looks like the point is going to go to Omri coming in with 615, and the first person to come in with 615. So very nicely done to Omri. Guys, give a GG to Omri in the chat. GG, Omri, you earned the point today. Points are just for fun today, but you still earned the point. Very nicely done. Very nicely done. Alrighty, well, congratulations to everybody who took on this challenge, and let's move on and take a look at the next challenge here. So our next challenge, challenge number 2, is going to go live here. I want to make sure you guys have enough time for this one, so here we go. Omri earning his first point. Good job, congratulations. Here we go. This next challenge goes live in 3, 2, 1, go! What is the mass of this part in 0.xxx pounds? Okay. We got a challenge here coming at you guys in inches and being asked to be solved in pounds. And it's a sheet metal challenge. You don't have to do it with sheet metal, but it'll probably make things a lot easier if you do. And the general notes here say that the default wall thickness is 0.125 and the default inside bend radius is 0.250. So you guys got a nice little challenge here. This one is a little tricky. It's going to take you some time. Good luck. I'm going to leave that up on the screen just for a minute. I'm going to start doing my my due diligence, examining this. Actually, you know what? I'll do this live because you guys might want to see this. Might be a good learning lesson. If something goes wrong with a model, what can you do to try to get it to go right? So I'll leave this up here. I'm going to take a sip of my beverage, and we are going to see what we can come up with for this one. Midlife Crisis in the chat. What's up? GG, indeed. All right. I hope that was enough time for you to do a screen capture using Windows Snipping Tool or Snagit, MW Snap, whatever it is that you choose to use. And let me turn off the chat here in the overlay. And let's just take a look here and see if we can't figure out what's going on with this thing. So at this point, what I would do is I would roll back to the beginning of the tree, and I would one by one look at the different features and try to figure out where did I go wrong on this thing. I'm only off by a few grams. I don't know that, though. I just know that I got the wrong answer. So, I mean, in the tournament, I don't know. So let's go back. You know, a lot of times what I'll do at this point is I'll just roll the bar back to the beginning of the tree, and that way I can really remember and understand how I built this thing. So we'll start with this first sketch here. You can, in Onshape, you can double click on the sketches to get into edit sketch mode. And I've got a diameter here of, okay, here's the error. Wow, I found it on the very first feature. So this is supposed to be 30, this is supposed to be, so this is how you read a hole call out. 18 millimeters is the diameter through, so that's this right here. 18 millimeters is the diameter through. 31 is the diameter of the counter bore, so this symbol here means counter bore, so 31 is this diameter here. A lot of times on my prints, I'll give you guys little hints, little reminders, like down here. I say, hey, just remember, this is 31 because that's the counter bore. And then 11 is the depth. Well, look what I did. I made 11 the diameter of the through hole. So here it is, 11. That's supposed to be 18. That was pretty fast troubleshooting. The very first feature we looked at had the problem. All right, so now that's 18. So now let's exit that sketch. Let's roll this thing to the end. And let's once again take a look at the mass properties. And the mass properties of this are, boom, 2484. And that is correct. Good job, TooTallToby. Oh, yeah, nice. Reed in the chat giving some pro tips out here to Mac users. Command-Shift-4 for screenshot for Mac users. Very nice. Very, very nice. Good one to know about. Print screen for Windows users. Print screen still works to just capture the whole screen. Although I think you get all 3 monitors, so. Or however many monitors you have. I'm not trying to flex, but, you know, if you're a 3-monitor user. All right, good deal. All right, so we got that one correct, and that is how you go through and you model that challenge in Onshape. Like I said, we saw this one between the Fusion 360 user and the SolidWorks user during the tournament, and unfortunately, neither of them got the correct answer, but it is not an easy model. You know, some of these models are a little more difficult, some are a little easier, and it's all up to the wheel of fate to decide who gets which models. Just some quick updates here in this middle part of the show, and then I'm going to do another model for you guys using Onshape. We do have the new build of TooTallToby.com coming out here any day, probably this week, next week. We'll see that first users being invited to this new build. So we got some really cool upcoming events on there. The TooTallToby.com current build has a calendar section where you can go and you can grab a reminder for all of the upcoming events that we have here on the TooTallToby. I don't know what you would call it, the TooTallToby ecosystem. There's a section on TooTallToby.com called Tips, a section that I've been working on a lot lately to try to get this to be kind of a repository for tips and tricks for different CAD systems. So you can see here that when you go to TooTallToby.com/tips, or if you go to TooTallToby.com and go to the top of the page where it says Pro Tips, we've got all these different tips here. You can filter by SolidWorks or Onshape. So if I click on the Onshape filter, the page reloads and it only shows me tips that have to do with Onshape. These are basically videos that I've posted that are, you know, quick 5-minute tips to help you navigate the software a little more efficiently. If you only wanted to see tips that have to do with SolidWorks and that have to do with sheet metal, well, you could filter by SolidWorks, filter by sheet metal, and then you just see some tips there to help you save some time. These aren't like big, long tutorials. I'm building another section of tutorials that are more step-by-step how to build a specific model. These are more like, hey, if you learn this tip and you start using it, you're going to save hours every week. So just different tips and tricks on SolidWorks, different tips and tricks on Onshape. Most of these are redirecting to the YouTube channels that tell you how to do these different things. And it's just a great way for you to kind of go through and to get some different tips and tricks, get yourself a little bit more efficient using SolidWorks or using Onshape. Wow, Eric already coming in with an answer. What a flex. That was fast. Very nice. No Eric in the tournament this year, though, huh? We got to get Eric back in the tournament next year for sure. And I do offer some training. I do have a CSWP prep class that's going. We'll have more stuff on training when the new website rolls out as well. But I do offer, a lot of different training opportunities. If your company, if your team ever needs some training, let me know. Just hit me up, TooTallToby.com/contact. That's the best way to get in touch with me. And we'll definitely reach out to you and talk to you about training. All right, so then when we were during the tournament this weekend, when we moved into the red bracket from the green bracket, we saw our first showing of Onshape. We saw Onshape versus SolidWorks, and we saw this model that Imant's modeled up in SolidWorks, but unfortunately, Ricardo was his screen locked up. There was a technical issue, not on his end, just like between him and me. The broadcast that he was using didn't come through, but he was still in there modeling this thing, and their answers came in within a second of one another. Super, super close match here. It was Imant who got it correct first using Onshape, but I wish I could have seen what Ricardo was doing in the background. But then we moved on to the next match, and they were challenged to build this part. And this part was pretty cool. It gave them both kind of a little bit of a struggle, a little bit of a fit. And I think that the thing that made this part challenging was the section view up here in the corner. And so when we look at this section view here, you can see that, it's got all the information that you need. And the instinct that a lot of CAD users have is to create the center line here and then to create this geometry from the section view, and then to just kind of jump into the revolve command, just kind of create everything here, and then just jump into the revolve command. And most of the time that is probably good instinct, but you have to first kind of just before you look at the views and you just right away jump in and start creating the geometry from the views, you really have to look at what the model itself is representing and kind of ask yourself, what's the best way to create a model like this? And what I usually do as an experienced CAD user is I break the model down into different sections, and I name those sections in my brain. You name them some kind of a section that's gonna, some type of a name that's gonna make sense to you logically, a functional name. I don't necessarily know what this thing is or what it's doing, so it might not be the correct term in engineering language, but just in my brain, I give it a name. So for example, this section here, it's like a tapered section. It looks almost like a red silo cup turned upside down. This section here, I would probably call something like the hub. That's the middle of the model. I would probably call that section the hub. And this section here that's going around the outside of the model, well, I would probably call that something like the rim. And again, this is just in my head, just as I'm imagining the model. And then finally, this section here, we would call that the spoke, right? Like a bicycle wheel has a spoke on it. And so if you take the model and you break it down into those three sections, then it starts to become questionable if you should be taking this strategy as your first sketch. I would think that it would make more sense to make your first sketch maybe look something like this, where you're just creating that shape and you're going to revolve that shape. And then maybe your second sketch looks something like this, where you're just creating that shape and you're going to revolve it. And then your final sketch, your third sketch, looks something like this, like the spoke, the extrusion for the spoke. And then you're going to take that extrusion for the spoke and you're going to create a pattern of that spoke. And then maybe you would finish up by creating the counter board that's going through the center of this thing. So, there's a lot of different ways that you can do this. But I think that, you just want to remember, sometimes it really pays off to just take those extra few seconds to look at the model and to come up with a game plan. And that's not only in a speed modeling competition, but it's also just in the real world. In the real world, a lot of times it's good to kind of take a minute, think to yourself, okay, how am I going to build this thing? Are there going to be dependencies? Is this thing going to change in the future? And so I'm going to have to go back and make changes. And by asking yourself those questions and using those answers to come up with your game plan, a lot of times you can really save yourself a lot of time. So I'm going to take a screen capture of this. I'm going to move this over to my second monitor. Eric says, I would just do it all in one shape, one revolve for the first two bodies, and then extrude the spoke separately. Yeah, that's what I think our runners were trying to do. I think that was kind of what was in their mind at first, but things got a little bit hairy when it came to doing the revolve and choosing the correct profiles, because what you have to remember if you're going to do it that way is you have to remember to include this break here, and you have to remember to include this break here. Otherwise, Onshape is going to want to, it's not going to know that there's a break there, and so it's going to want to revolve this whole thing, and you're going to be left with that extra geometry, and then what are you going to do? You're going to try and do a cut extrude from the top down. That's actually what kind of the situation that Ricardo found himself in, and it was really interesting to watch them both kind of thinking through that challenge. So you make a good point. It's just you kind of need to remember to include that break, and sometimes if you don't see that break right there in the section view, it's easy to overlook. So let's see if we can follow that game plan. Let's see if we can create this model. I'm going to do create document. I'm going to call this one 23-T-13. And that way, if you want to, if you want to kind of examine this model yourself, just get a free account for Onshape, onshape.com/free. Or if you already have a free account, or if you're on a paid plan on Onshape, you can just search the public space and you can find this document. And so I'm going to start a new, actually, I'm going to go into my settings. I'm going to change my workspace units. So let's make this one inch, and let's make this pounds so we can get the correct mass in the correct units. And then I'm going to go front plane, begin a sketch, orient my view, and I'm going to create that first shape. I like to keep my sketches nice and simple. Keep your sketches simple. That's what I'm all about. And so the height of this hub region here is 2.25. The diameter here, certainly I could create a center line here. So create a center line here like so. That way I can actually get the double dimension, or I could type in the dimension and then just type a /2. Both techniques are totally valid. This is going to have a diameter of 4.5, and this is going to have an angle here of 43/2. 43/2, because it's 43 across the whole thing. We'll jump into a revolve feature here. We'll say that we're going to revolve about this axis, and that gives us our first feature. Nice, simple sketches. That's what I like. Front plane, I'm going to begin a sketch again. I'm going to create a circle. I'm going to, once again, create a center line. So I begin dragging this line. I tap Q on my keyboard. That jumps me into the center line command. And I'm going to say that this has an overall diameter here of 9 inches. And I'm going to say that the circle has a diameter here of 1.5 inches. And that the height to the center of that rim, remember, I'm not naming it necessarily anywhere. I'm just naming it in my brain. Just using my brain to keep track of things. So there we go. There is the rim. And now I'm going to finish this thing off by once again going to the front plane, beginning a sketch, and creating a sketch for the spoke. And I think that I can probably get away with creating the spoke like this. I can create the spoke in a way that it's it's directly embedded in the hub, and it's right in the center of the hub. And I think that's going to be okay for this this example. So it looks like the spoke has a 1-inch dimension here between these two parallel lines. It looks like the spoke has an angle of 25 degrees here. And it looks like the spoke has a distance to this corner of 7.25/2, because I don't have the center line this time. And it's got a distance to this corner of 1.75. So there is our spoke. Let's do an extrusion there. Let's make that extrusion symmetric, and we'll say that extrusion has a width of 0.25. And there we go. There is our spoke. And we're going to say that that spoke is going to be patterned. So we're going to jump in here to the pattern command here. We'll do this as a circular pattern, and that is going to be patterned using this part, the spoke part. And we'll pattern here around this axis, and that's going to be 8 instances of that spoke. And then we're going to take all those different bodies, and we're just going to merge them together. So we'll do a right mouse button here, Boolean, and we'll do a union. And that way we merge everything together. And now we just need to finish off by adding a hole here. We could do this using the hole feature. There's a counterbore option for that hole feature. And that counterbore option is going to be with a dimension here of through dimension of 1.5, counterbore dimension of 2.75, and counterbore depth of 0.75. And then if you use this option here for select mate connectors, then that allows you to just pick the center of this face, nice and easy. Boom, there is your counterbore. And that is how you can model that part. Let's assign the material here. Assign material coming right from the TooTallToby library that's on the public space. And this material is plain carbon steel. And we'll click the mass option for this. And the mass is 17.46. And that is correct. 17.46 is the correct mass for this model. So we did it. We got it correct. GG, Toby. Nice little speed run through that model. Hopefully that gave you guys an opportunity to see what it would look like. Rich Penn is in the chat. What's up, Rich? Thank you very much for the GG. In the tournament, we would have to take this number, Control C, go over here to the chat, Control V, paste that in there so that, we could be judged. So we can make sure that it's valid. But yeah, that's how I would go through and model that part. And I think that the big lessons there from modeling that part, again, are keep your sketches simple. I know it's true. You can absolutely include everything in one sketch. But sometimes, you know, if you want to see an example of where that can go sideways, take a look at the tournament footage from this weekend. Sometimes having everything in one sketch can actually be prohibitive, and you can actually be a little bit better off modeling, you know, your features one by one. It's, you know, it's something that I think is debatable when you're speed modeling, but certainly when you're modeling professionally, and especially when you're modeling on a team, the ability to simply rename these features can make such a difference to your teammates. So, you know, if this first sketch here is renamed to something like sketch, and then I'll just call this one hub revolve, and then this feature here is renamed to hub, and then maybe even call it hub revolve. You know, what I'm doing here is I'm kind of leaving love notes here to my teammates. So I would call this one, you know, rim or outer rim revolve. You know, I'm kind of leaving love notes here to my teammates so that they know what to expect when they look at this model. They can just look at the model and they can see like, oh, okay, I can see. I don't have to roll anything back. I don't have to look at the history of this model. You know, I can just see right from the tree how Toby did this. This is the, I'll call this one pattern of 8 spokes. And that can be really useful when, you know, when your client comes to you and your client's like, actually, I don't want this to be 8 spokes. I want it to be 6 spokes. Well, when you can just immediately identify which feature is driving that geometry, that's going to make for much better design review meetings with your clients. Your client's going to have a lot more confidence in you as a designer, as an engineer. You're going to be like, no problem. I know exactly where that feature is, as opposed to being like, okay, hold on. I have a couple different revolves here. I'm not really sure which one was the hub and which one was the thing and which one was the spoke. Hold on. Let me roll back. Let me roll forward. Like, your client's going to have way more confidence in you if you just say, yeah, no problem. You want that to be 6? Sure. Let me just change this real quick. Make that 6. How's that look to you? You know, and then they're going to look at that and they're going to be like, wow, that looks great. And then all you got to do is just go back here and remember to change this back to 6, you know, rename the feature. If you don't want to have, so this gets a little more nuanced. Sometimes, you know, people will say, don't include any numeric values here in the tree because they're not going to update dynamically. Although I'm sure Airwick could probably write a feature script or something like that to have us show the numeric value directly in the, you know, directly in here. So, that's the idea of, you know, working here with a, you know, kind of a speed modeling challenge, one of the speed modeling challenges from this weekend. Aaron C is here in the chat. He was the star of the tournament this weekend. What's up, Aaron? Welcome, welcome. Thanks for joining us. All right, guys, I hope that I gave you enough time. I know that sheet metal challenge is a little difficult. I think I'm pretty much at the end of our presentation. Don't forget, if you enjoy this type of content, be sure to like. What do we got so far? We got 24 people watching. We got 16 likes. Let's see if we can get that to match up. 24, 16. Let's see. We could probably even get it to be more, right? Because some of the people who are watching now probably weren't here earlier. So let's make sure that we get that like ratio to match up at least at 1-to-1, if not more. Remember, the other way that you can help support the channel that is awesome is just to share and reshare. If you see what we're doing here, if you enjoy this type of content, you know, just get the word out there, take a screen capture, throw it out on the internet, you know, show that we're creating these models, show the chat at the end. Maybe like when I'm showing the answer and I've got the chat overlaid on the answer and I'm highlighting the different people's names, grab a screen capture of that, throw it out there on the internet and say, this is really cool. This guy does this every Monday. And if you guys, you know, if we keep sharing and resharing, we're gonna get this channel up to. We just crossed over 8,000 subs, guys, this weekend. 8,000 subs. It went across yesterday. So I remember it wasn't that long ago. We were at 69. Made a video on that one. Now we're at over 8,000. So we're gonna just keep going. You know, keep on growing, keep on going. I think it's a really fun format that we've got here, and so I think we're gonna just keep getting people involved. It's gonna be awesome. If you guys want some more practice, I have like 50 different practice models here on the YouTube. You can always go through and look at those practice models. I'm kind of reviving some of the ones from the old days, bringing some of them back. I know some of those ones from the old days were really good. They got kind of purged out right around that magical January 4th, 2022 date. So we purged out some of the old videos, and we're kind of bringing back some of those examples, a little bit of retooling on some of them, but there's over 50 models on the practice models playlist, and definitely worth taking a look at if you want to get some more practice, whether you're in the tournament or you just want to practice for fun, just to sharpen up your skills. All right, guys, this brings us to our answer. What do we think about this model? This is a tricky one. I think for me, if I'm looking at this model, I mean, there's a few different ways you can approach a model like this, but I think for me personally, what I'm probably going to do is I'm probably going to start out by creating this shape here from the top view. So probably this shape, just half of it. You know, let's take advantage of mirroring. And then I'm probably going to extrude that down, but I'll stop short. So I'm not going to extrude it to the 4 full inches. I'm going to extrude it to 4 minus 3.75. And in most, well, certainly in SolidWorks and in Onshape, you could type in 4 minus 0.375, and that's going to give you the math. You don't have to do the math. It's 3.65, just in case you guys are wondering. But you don't have to do that math. You can let the software do the math for you. So now, once I create that shape, then that's going to set me up nicely to do what's called an edge flange. And when I do the edge flange, I can modify the profile to create this shape. And then I can do another edge flange, and I don't even need to modify the profile to create this shape. Then I would go in and add these radii 0.25. I would add these holes, and I would finish up by trying to remember to add this hole, which is very easy to forget. And I've seen a lot of people forget. Oh, I forgot to mention, sorry. After I do that first feature, then I would do a cut extrude, and the cut extrude would look like this. Probably I would just include that radius in the cut extrude, although certainly you could just do it as a triangle and go back after. But I would do a cut extrude as my second sketch and cut that initial flange off like so. Brian Jackson is here. What's up? What's up? Welcome. Thanks for joining us. All right, guys, let's see what the answer is for this one. We're coming up against the top of the hour here. So who got it first? I think it was Airwick. Airwick came in here 0.5458 and then revised right away 0.5289. Nice. Oops. Oh, and then revised again 0.4722. AMO Alex coming in 0.489. Very nice. Very nice. Let's see here. We got Waddy 1940 coming in 0.5 pounds. You got to increase your precision there on your mass properties to get that out to that 3 decimal places. We got Raja Muhammad coming in 0.492. Raja Muhammad, another person who's in the tournament a little bit later in the tournament season here. All right, I think that's all the answers that I'm seeing here. Let's find out what the correct answer is. The correct answer is 0.472 pounds. So who got it first? Looks like it was Airwick on his third try, 0.472 pounds. So let's give a GG, a good game to Airwick, excuse me. Good game, Airwick. Congratulations, Airwick. Very nicely done. And GG really to everybody. GG to everybody who participated in the challenges today. These were not easy challenges. They took me a while when I was going through and auditing them, so I know that these are not easy. And GG to everybody who gave them a try. And if you haven't given them a try yet, or if you're watching the recording, good luck. These are definitely some challenging. I'm reviving some older challenges that we did. I'm going to load these into the practice models playlist as well. But these are definitely not easy. I guess in the old days, I really I gave you guys some tough ones. But, you know, Model Monday Live is going to be a little tougher than the tournament in the round of 32 anyway. So this is good practice for all the tournament runners out there. All right, guys. Well, that does bring us up to the top of the hour. So I want to say thank you all so much. Congratulations to our winners. Congratulations to Airwick. Congratulations to Omri winning his first point. Very nicely done. Very nicely done. And thank you, of course, to all of you. You guys are indeed the greatest chat on Earth, certainly in the 3D CAD space. Don't forget this Saturday, July 29th, we got Golden Spamfish going up against Momin, Onshape versus SolidWorks, and another epic showdown. And then we flip over to the blue bracket, and we've got Katia versus SolidWorks. Muhammad, old friend of the show, going up against Res using SolidWorks. So very excited to see how those showdowns go down. We got SolidBox as our sponsor of the blue bracket. We are still looking for a sponsor for the black bracket, the green bracket, and the red bracket. So if you know any companies out there, or if your company might be interested in sponsoring this tournament, let me know. Reach out to me. We can definitely talk about what that entails. And that's it. We'll probably do Model Monday Live next week. I know this date is wrong. It's actually the 24th. Model Monday Live next week, 2 p.m. Nope, it's going to be at 11 a.m. I like this 11 a.m. slot. It really works well for me. I hope it works well for all of you. It gets the week started off on a great note. And so we'll do Model Monday Live next week at 11, unless something comes up. I know I'm going out of town for a few days next week, but I think I'll be here on Monday, so it should all work out just fine. And again, I want to thank you guys. You guys are the best chat ever, and I look forward to seeing everybody on Saturday in the live stream and next week in Model Monday Live. See you guys. Have a great Monday. Have a great rest of the week.